So, good morning, everybody, and welcome to today's webinar, How to Valorize Biowaste, Valorization Pathways from EU-funded projects. I'm Giulio Poggiaroni from ETA Florence. I'm involved in the Bean2Bean project, and this webinar is a joint initiative by Bean2Bean, FENIX, and bioSOILUTIONS projects, which have joined forces to start to develop some joint initiatives in the field of biowaste valorization. So, as you saw from the agenda, the presentation today will follow in a row. We will have Sara Daniotti presenting the Bean2Bean approach. Sara is from Consorzio Ital Biotech. Then we will have Miriam Romero from Inveniam, who will present FENIX, and then Belén Miranda, who will present bioSOILUTIONS on behalf of SAV. So just before starting, a few housekeeping rules. You can use the Q&R tool to post your questions, because at the end of the presentation, so in the space of 30 minutes, let's say, we will open the Q&A session, and you will be able to post your questions using the Q&A tool. We will use the chat just to share links and information about the webinar and future activities. So without further ado, I will give you a very brief introduction on what is biowaste, because we thought that it's important to start from the same page, so that we don't have to repeat certain concepts and certain aspects. So, what is biowaste? According to the European Waste Framework Directive that dates back to 2018, biowaste is composed of two main elements: food and kitchen waste and green waste. So food and kitchen waste, of course, is the food scraps like vegetables, fruit peelings, and other organic residues that are usually produced by restaurants, canteens, retailers, and in our households, in our everyday life. And then the second part of biowaste is the green waste, so the grass cutting, falling leaves, hedge and shrub trimmings, and all this kind of stuff that are derived from the maintenance and handling of green areas. Still, according to the directive, biowaste does not include forestry and agricultural residues, manure, sewage sludge, and other biodegradable waste. So this is the first thing we want to point out. Then one big concern that we keep on repeating is that biowaste is a precious resource, and sadly there is too much waste of biowaste, because we know from the available data that around 68% of the biowaste generated in Europe ends up in the residual waste bin. And usually the waste in the residual waste bin tend to end up in three different destinations. So landfill, which we know is it's very bad. It's at the bottom of the pyramid that we will see in a while. It can end to incineration, where energy production is involved, but there are still some emissions involved. And then according to the hierarchy pyramid that we will see in a while, energy production is not a priority over recycling. And then you have different ways of mechanical biotreatment. And now getting to the pyramid I was mentioning before, we know that at the European level, the first thing to do is to avoid waste, so prevention. We know that there is a lot of bio-waste being, of food waste being produced, and so the first thing to do is to avoid this. Then you have the reuse. For example, food which is still not waste, but it's given away from the restaurants or from the supermarket can be reused, especially by food banks, by charity organization. This is what we can label as reuse. And then once we have the so-called inevitable bio-waste, we end up in the recycling phase. So inevitable bio-waste is what cannot be avoided. For instance, once you eat the banana, the skin of the banana, of course, is inevitable bio-waste. And then this inevitable bio-waste should be separated at source or separately collected via door-to-door systems or bins located in the streets. And then after this, you have different valorization pathways, which are what we will discuss today, because the three projects available at present today will present you different valorization pathways that are being implemented or being developed in different countries and different cities in Europe. Just to remember, this is very important because the directive I was mentioning before has mandated that by the end of last year, European member states have to implement the separated collection of biowaste. So it's a mandatory thing now in Europe. Of course, we know that directives take time to being transposed into national legislation, but it is a reality now. One last comment is about the Roots Group, because some of our organizations involved in the three project were in the past involved in Horizon 2020 project that already worked on the valorization of biowaste and how policy could meet these new opportunities arising from technologies and valorization pathways being developed. So in a way, this webinar wants to be the next step of this group that released this paper that I will put you in the chat, the link, so you will be able to download, and hopefully we will bring forward this work in a future policy paper by these three projects that are present today. So without further ado, I can move to the first speaker today, which is Sara. Sara is from Bean to Bean, and she will introduce the project and the valorization pathway. So Sara, the floor is yours. And you can remove the mute.
I found it. Sorry. Okay, can you see my screen?
Yes, we do.
So myself in the screen. So let me share my slide in presentation mode. I reduce myself and then be on the slide. Okay, perfect. So thank you very much, Julia, for this introduction. As you already mentioned, I'm going to present very briefly myself. I'm Sara Daniotti. I work in Consorzio Italbiotech as a head of bioeconomy project management unit. And I'm also the project coordinator on Bean to Bean. So today I'm really glad to present our project, focusing on the concrete outputs that we would like to develop within installation. Forward. Okay. So about the project, you will see when the other projects will present their approach that ours is a little bit different from its sibling, as we do not focus directly on implementing one or a few technologies for biowaste valorization, but we try to propose a wider approach to help European cities in their transition towards healthy soils. In particular, what our approach aims to support innovative and economically viable value chains that can optimize biowaste recycling into soil improvers. In particular, we focus on urban biowaste, so the biowaste that you produce at home, biowaste that are produced from supermarkets, from restaurants, and also on green waste that are produced, for example, by trimming green areas in your cities. And with this idea, we want to establish these circular two-way loops with between food production and healthy soil. So not only healthy soil help improve food production, but by valorizing food waste that come from food production, we can indeed benefit the soil. It's moving, okay. So 2 words about who we are. being implement this interdisciplinary approach that involves 11 partners from 7 countries in Europe, and you can see circled here our 3 living labs that I will present later in detail. So a little bit about more about the bean-to-bean approach. Our project aims to help to solve the more impelling issues of waste production and recycling. And in particular, we acknowledge that there are already a lot of solutions in our cities for recycle and valorization, but this solution usually, or a lot of the time, are hindered by several limitations that could be at the level of collection, could be related to legislation, really a lot of challenges. So what the project would like to do is to valorize the existing local initiatives and solutions instead of proposing new ones, while addressing local needs and challenges in order to remove these limitations to their development. In particular, to reach its objectives, the bean-to-bean concept starts with indeed mapping local needs, local limitation, and especially the already existing solutions that are already available in a city. Once identifying this solution, are assessed for their safety, environmental, and socioeconomic performances through the co-creation of a tailored evaluation framework, which will be then used to select the most promising solution to be boosted economically. And finally, after this selection, we will develop these local and personalized business models to boost commercialization of the solutions. The model will be tested in 3 cities, our 3 living labs, bringing to the selection and development of different local solutions. Besides the development of the solution itself, we also aim to create concrete tools for the cities to replicate our approach and be able to move forward their own solutions towards commercialization. So some more details about our outputs, our concrete results for the city. First of all, we will have this toolbox with roadmap and guidelines. It will be aimed to cities, municipalities, waste managers, and the aim is really to guide cities toward replicating our approach. So we will have this roadmap guiding the cities towards using our guidelines, our tools that will focus on bio-waste collection, but also safe and sustainable production and use of soil improvers, and will also give suggestions on how to maximize the market uptake and economic viability of the solution. Another important and interesting output will be this application for end users to select the best soil improvers. In particular, we aim to update an already existing platform that is accessible by farmers, which is called Farm Apps, as you can see here, where end user will be able to provide information on their soil and soil improvers. And the app will then provide some information on the effects on soil health that the end user can expect when using that particular soil improvers. We expect to have maximum 3 soil improver per living labs in these maps, so that it could grant a benefit for the farmers and end users in general. Finally, at the core of the bean-to-bean approach lies this scoring system. that will be developed as a decision-making tool for cities and policymakers with the aim of guiding their decision towards which innovation and which solution are worth funding or investing on. The tool in particular will allow computing the overall performances of this solution by taking into account different type of indicator from the safety, including environmental, but also considering socioeconomic viability and the local context. This is a slide to have a closer look on the evaluation part, just to mention the 4 types of criteria that we would like to consider in our evaluation. As mentioned, our approach will be tested on 3 living labs that are part of our participatory approach. These living labs represent different pedoclimatic regions, but also are differently advanced on the topic of biowaste. For example, we have the northern central cities, Amsterdam and Hamburg, that are more advanced on the topic, and they will particularly focus on improving the quality of their biowaste, which directly affects the quality of the soil improver resulting from their valorization. While we have Egalio in Greece, that it is more at a transitionary stage with regards to biowaste management because of different knowledge gaps for the policymakers, but also in the citizens. So what they would like to achieve within the project is to put in place an effective biowaste collection and demonstrate different strategies for composting to restore green urban areas. A very last slide from my presentation. This is one of the concrete output and tools that will be part of our toolbox for cities. We developed this handbook of recommendation and good practices that establishes the status quo of existing knowledge, approaches, solution along the entire value chain for biowaste valorization. This handbook will include the good practices, results, concrete examples from cities that come from publication, cities interview, consumers interviews, and interviews with directly with solution provider. As a result, this handbook will identify the main step to ensure the effectiveness of biowaste to soil recycling system. And it's based on this iterative and participatory approach. It's not yet published, but will be published very soon. So stay tuned to know more and to read our handbook. These are my contact details if you want to know more, and there is also our website if you want to have a look on what we are doing. Thank you very much.
Thank you very much, Sara. So just to mention, in the chat, I've put the links to the 3 project website and to the roots paper I was mentioning in the introduction. Then it's time for the next presentation by Miriam Romero from Inveniam Group.
Yeah.
Yes, we see you, Miriam.
Perfect. So thank you very much for the introduction. Also, thank you, Sara, for presentation of your project. I'm here. My name is Miriam Romero from Inveniam Group. We are the work package leader of the project FENIX. FENIX, as you will see, it's quite different from bioSOILUTIONS and from B2B. It has a completely different scope, but really targeting to the same, almost the same objectives. So let me see. Okay. So disclaimer, sorry. Just a very short introduction or presentation of the team that conforms FENIX. FENIX has 9 partners around Europe, mainly from Spain, whose coordinator is Universidad de Granada, France, Greece, and also Denmark with the Institute. And we have it's 50 months duration, and we are more or less in reaching month 18 of the project, so almost 1/3. So Julie already introduced very well this part. So we have a problem with biowaste, and the EU targets to revalorize biowaste on 65%, but 2 years ago the value was only 34% in Europe. So what means that we have still a lot of challenges and a lot of things to do. So the current options are for energy purpose, that as we saw in the pyramid, it's one of the least options. And also we have composting, but also composting has some challenges that maybe we need to find out also other solutions. So in FENIX, we focus on 2 types of biowaste. We differentiate them between non-fermentable, for us it will be to obtain biochar, and the fermentable ones that will be to obtain digestates. So Project FENIX starts with, let's say, a starting value on where the biochar so far is saw as a really promising solution that enhance soil water holding capacity, nutrient uptake, and soil fertility. It stimulates microbial activity. It also acts as a carbon sink, so why to not use it broadly? Because mainly the agronomic benefits remain still untested. So it means that we don't know if on the future we will have benefits, or even we can even reverse the situation and make it even worse. On the other side, the digestates are a really promising solution also to make that these biomethane plants can be more profitable, and also to take advantage of this biowaste recycling, not only to generate energy, but so far, as said, so for the majority of anaerobic digestion plants, this is a cost for disposal. So it's considered against a waste that it's at this time it's considered, or it's sent to landfill. It's worsening the situation. And also it has a lot of difficulties to find heterogeneity on the feedstock. So it's also a big challenge that we need to face in order to make or further use of digestates. So what FENIX aims? So we aim to contribute to the recovery of abandoned poor soils for agriculture to increase the quality and water reduction capacity, and also contribute to the climate change. But how we're going to do that? So as Julia presented at the beginning, considering the bio-waste description from the European Commission, we choose the green waste from the cities. So it means that the pruning residues from the cities, mainly we have 2 types, from winter and from summer pruning, and then that will be the part of a non-fermentable waste to obtain biochar through the pyrolysis, and then the supermarket bio-waste, and that we send to the anaerobic digestion, and we obtain the digestates. Then the main focus of FENIX is to find a formulation that really impacts on soil. So it means that can recover the soil fertility and can recover also the soil health. So step by step, what we're going to do. So we're going to produce biochar at lab scale using these different kind of green waste that we mentioned before. And so produce them in order to find the characteristic desired for soil application. So then after producing 36 types of biochar, combining different production parameters, we select the 4 best ones targeted as set for the soil application and improvement. Then we mix them with the digestates that also will be characterized in order to make sure that we do not miss it. And then we will test them, so this mixture in different doses, also to see if it's better, maybe more biochar or more digestates. So it's effective on soil. And for that, we will use real soil, so not only bot testing. That we will have 3 fields located in Spain, 1 in France, and another in Greece. So to also test different soil conditions and soil use. And what's more, we will also characterize the gaseous emission and organic nitrogen mineralization potentials of this soil improver that we will develop, and we will do a computer simulation that will also serve as decision-making tool. So it means that we can have any kind of soil, for example, or the user can introduce the characteristic of their soil, and they can choose what is the best doses or what is the best biochar that they need to use for their soil, so to obtain the desired results. And also on the other side, we're going to test the biochar as an additive to enhance the microbiological activity in the anaerobic digestion. So we have seen, and there is a lot of literature regarding the synergies that there are between the pyrolysis, so the biochar, and the anaerobic digestion. So we will also have a small line of research on this aspect. So what will be the outcomes of the project, and what maybe the audience that is here today can take off? So I said one of our main objectives, and we want to impact this on new and improved demonstrated products. So in this case will be a soil amendment, and then to create also a new value chain and services available. So first, I said we want to develop an alternative soil improver, so getting out of the chemical products that are currently available in the market and are mainly used, and to demonstrate the benefits of using, let's say, natural products or products out of biowaste. Also to improve and demonstrate the process efficiency. So we, of course, the Pérez technologies and also the anaerobic digestion technology face some challenges. So we want to overcome these challenges, proving the economic viability of doing that. And I was saying before, also create new value chains. So let's say that the energy generation and the agronomic sector were before quite unconnected. So now it's to link the biowaste generation, so to create a complete new value chain. On the other hand, we also have to improve the environmental health of soils, and also about soil improvers on whatever is related to production, operation, also including the testing methods to improve their life cycle, or to prove that their life cycle is not worse than maybe the commercial competitors. So as said before, so we want to improve the soil quality. This is through we have some more technical words here, but in different aspects. That's why we will test our product in 5 different fields. We also want to demonstrate the ability to avoid and even sequestrate greenhouse emissions. So this could be really relevant for agricultors, as there is a new way of generating money, let's say, sequestrating emissions with carbon credits. And this is something that we will investigate also on the project, on how this can be demonstrated and how the product can demonstrate that it can sequester carbon and mitigate the climate change. So it can be also an option for agriculture. As we mentioned before, also to develop this long-term effect simulation tool. So we don't only want to, so as you may know, it's quite difficult to prove the long-term effect on carbon sequestration. So that's why we will take the results from the project, from the different field testing, and put them in a model to obtain the long-term effect. So as I said before, that one of the challenges of the biochar was that we don't know the effects on the long term. So in the project, we will make sure, or at least simulate, that on the long term, we don't have a negative effect, so that we should avoid using this product. And also, importantly, the regulatory roadmap. So it's worthless to be working on a soil amendment that aims to and avoid the land erosion, but if we are missing or totally the regulatory in place. So for this, we will, from the really beginning, so from the design phase, we are making sure that all these policies are accomplished, and if in the future we see that there is a blocking points, also to make recommendations so to avoid that the uptake or the use in the future of this kind of products can be widely extended. And I think this is the last point. So we want also to improve the nutrient recovery from biowaste. That this is one of the main targets of the project. So improve biowaste recycling of this kind of waste that is sent to landfill currently, and to have a more profitable value chain, and then the recovery of this biowaste through the more known NPK nutrients. So this is through the digestates, and also increase the anaerobic digestion and pyrolysis processes economic viability. So as said before, so increasing the valorization, or by valorizing all the byproducts by these technologies makes that also the viability of these kind of technologies is also increased, and we can at the end ensure that biowaste can be valorized effectively. And last one, improvement of the digestate stability and ability to retain water, because one of the main drawbacks of digestate is that they are quite unstable. It's very difficult to transport them. Usually they can only be used really locally, and mixing them with biochar, we expect that we can also improve that, and they can be transported further instead of being utilized only on the local farms, for example. Sorry, I missed the last one. And enhance the entrepreneurship on regenerative processes, creating a spin-off company or a joint venture between this value chain that we are representing in the project through this FENIX business platform. This is something that we are still working on it, defining, and most probably will be available by the end of the project. And as I said before as well, I don't want to repeat, also to look for the synergy between the best way of recovering in waste and fermentable biowaste as supermarket waste through the anaerobic digestion and pyrolysis for the production not only of energy, but also of soil improvers. And that's it. Thank you very much for your attendance.
Thank you very much, Miriam, for the nice presentation. So in the meantime, I would just want to mention that the recording of this webinar and the slides will be available after, of course, the end of this session on the project website. So you will find then in the news section the recording and the presentations to download, especially for those who have connected after the start. So I'm now giving the floor to Belén for the presentation of bioSOILUTIONS.
Okay, thank you. Thank you very much, Julio. I am going to share my presentation. And before that, I would like to say thank you to all of you, to all the audience for attending the webinar. I hope it's going to be helpful and you find it interesting. And thank you all to our project sisters, Bin2Bin and FENIX, for collaborate and develop this webinar. So, okay. This is my presentation. You can see the full screen. Okay, yes. Perfect. The BioSOILUTIONS project, this is the complete name, is transforming biowaste into safe and effective soil improvers. And firstly, just to put in context the project as a brief introductions, I would like to say that soils are, as you already know, are finite natural resources with critical socioeconomic and ecological functions, including food production, biodiversity conservation, and regulation of water supplies. Today, between 60 and 70% of soils are degraded across the European Union. due to unsustainable soil exploitation and the disproportionate use of synthetic chemicals. So, in addition, soil degradation is expected to increase in the coming years because of climate change, increased land use, and unsustainable practices linked to human population growth, resulting in direct negative consequences on the food supply chain, environment, biodiversity, and human health. So, with this context, as we will see an overview of what soil improvers are. These are inputs added to soil in situ, whose main function is to maintain or improve its physical, chemical, and/or biological properties. So today, soil productivity is highly dependent on soil improvers, as their application enhance key plant production parameters no longer provided by degraded soils, such as carbon availability, nutrient bioavailability, moisture retention, or aeration. So many of the soil products applied today to maximize agricultural production, such as fertilizer or herbicides, contain synthetic chemicals like solvents, hydrocarbons, heavy metals, and so on, that actively contribute to long-term soil degradation via acidification, salinization, or toxicity. In addition to soil degradation, synthetic chemicals are responsible for a wide spectrum of environmental and health risks, and are highly energy consuming. So we have to take into account as well that the 16th of July 22, the new fertilizing product regulation entered into force with the aim to reduce synthetic product use and provide more restrictive CE marking requirements. So the new regulation introduced more stringent rules related to quality, safety, and labeling of fertilizing products. All of that we have to take into account. So how we can fight against soil degradation? Well, in bioSOILUTIONS project, we try to valorize through different pathways. The point is that the agri-food production system is facing the urgent need of finding sustainable alternatives to synthetic chemicals to ensure soil recovery while avoiding environmental and human health risks. So the main objective of Solution Project is the implementation of innovative and effective fertilizers produced from organic waste that fosters the recovery of soil quality and fertility through the reduction of the use of chemical fertilizer, as well as the circular economy by reduce organic waste that is incinerated or sent to landfill. Everything will be done in a co-creation process where the development of the circular economy and the entrepreneurial system participation will be essential parts. In order to achieve the objectives, we rely on coordinators and partners from previous key European projects, such as WasteUp, Valorise, and Excalibur, as basis in the consortium, in our consortium. You can see here in this slide the consortium. We are 11 partners and one affiliated entity, and between the partners of the consortium, we are 4 coordinators and partners from the main European projects, all of them regarding biowaste. The project will last 4 years. Here you can see a picture of our first meeting in September 23. And In the project, we are going to develop 4 valorization paths. Biosolution approach aims to scale up this for bio-waste valorization routes originating from key previous European projects. These 4 valorization paths are from insect trash, blood hydrolysate, and struvite and K-struvite, to produce new fertilizers that we will see in depth in the following slides. You can see a scheme of the valorization routes, and we will see later all in depth. Well, following the previous research activities from the Waste Up and Value Waste projects, BioSolutions englobes the development and scale-up of valorization routes to obtain efficient, market-ready bio-waste soil improvers as an alternative to synthetic products and the landfill incineration, landfill or incineration of the bio-waste. So the 4 valorization routes are: the first one is blood hydrolysate, which is following the research activities of Waste Tag project. The optimization done at that project was 400 liters per week enzymatic hydrolysis. In BioSolutions, we will develop new blood hydrolysate to soil improvers with high iron and nitrogen contents and 80% amino acids recovery for directed soils uptake. In this picture, you can see the whole bioprocess of the blood hydrolysate. The first step is the enzymatic hydrolysis, then we get a liquid blood hydrolysate. Then we will do the drying process, and at the end, we get the dry blood hydrolysate. The second valorization route is following key findings from value waste, aims to optimize pilot scale frost production, 15 kilos per hour, to obtain a product with a well-known composition. This is key soil beneficial components as chitin, organic matter, growth promoting organisms, and NPK. Will be concentrated, and potential contaminants or non-beneficial components will be separated from frost. And finally, a pelletization process will facilitate logistics and application in soils. Well, the third valorization route is following the value waste project as well. And struvite from bio-waste is a potential soil improver rich in phosphorus, and to obtain through anaerobic digestion of different bio-waste. Struvite will be produced at 1 meter cubic per hour. And the last one is key struvite from food processing wastewater. In this process, follow value waste project research activities, anaerobic treatment and reverse osmosis of food processing water from potato processing will be optimized in a pilot scale. You can see the whole process on the picture as well. And after the reverse osmosis, we can get the key struvite with very rich in phosphorus and potassium nutrients. Well, the validation, the validation are different combination of all of these valorization routes. We will do at least 10 formulations that will be validated in these 4 ways to validate. At laboratory level, effective organic carbon will be or is going to be analyzed to estimate the mineralization of organic matter in soils. Then at the microcosm level, growth parameters such as height, number of leaves, aerial and root biomass, and the effective availability of nitrogen, phosphorus, and potassium for plant uptake will be measured in order to assess soil mineralization dynamics. Then at greenhouse crop phosphorus dynamics to assess nutrient use efficiency or phosphorus. And at the field pilots, we will measure and validate crop nitrogen balance to estimate potential nitrogen supplies and HG exchange to evaluate environmental impact. And finally, at least 5 formulations will be tested in the living labs validations with the end users. These are the 3 living labs that is developed in the project. There are 3 places: Flanders, Valencia, and Murcia. And in these living labs, the activity of co-creation and co-validation of the development of the soils improving are going to involve all the stakeholders to the entire value chain to get the best biofertilizer. And the point is that the Valencia Living Lab is going to match with the European Green Capital of the city of Valencia that was selected in 2024, this year. So the results and the data: at least 5 fertilizers at the end of the project, validated data obtained from the optimization of the process from the valorization paths, and we will do the economic analysis from every processes to get at minimum 5 market-ready biowaste soil improvers. So to sum up, the concept of a solution project aims to accelerate the placing on the market of biofertilizers obtaining from the valorization of organic waste in order to reduce the use of chemical fertilizers, promote sustainable soil recovery, and improve the circularity of the entire system. You can see at the picture the 4 pillars of the project: the design and the validation of the project, the circular business models creation, market awareness, and key stakeholder engagement. And that's all from my part.
Thank you very much, Belén. So now we are heading to the last part of Q&A. So in the meantime that our attendees gather their thoughts in order to pose a question, I would like to pose you a single and short question. So I would ask you to answer quickly. Regarding policy, in your experience, not necessarily linked to this project, to your project that you are presenting today, what were the main regulatory constraints that you saw as the most relevant that hindered the implementation of biowaste valorization pathways? Maybe we can start from Sara to. Okay.
Thank you, Judy, for this very interesting question. In my opinion, and what we have seen since the beginning of the project is that we are dealing with a policy framework that need to balance the recycle and valorization with safety and quality. So we have quality standards that usually for a soil improver that usually fall under the fertilization rules and regulations that create that are useful for safety, but sometimes hinder the development of new technologies because it adds a lot of administrative burdens. So this is an issue. And another issue that we saw is that policy and political tools on this topic are extremely variable among Europe, but among also different regions and even in different cities. So it's really difficult to transfer solution, for example, but also to produce a soil improver in a city and say, okay, I will sell this soil improver in another city because maybe in another city you cannot use it. So this is why also it's, in our opinion, is very important to develop local solution and work with and not against the local context. I hope I answered the question in a short way.
Thank you. Miriam and then Belén.
Yeah, from our point of view, also one of the main challenges or issues are to really adapt the processes that we have. So the expectations of the value chain, let's say, to really apply and valorize the biowaste. Because sometimes we find that, for example, in aerobic digestion or pyrolysis, we cannot valorize or we cannot apply the products as they are, and they need a lot of intermediate process because maybe the regulation is not adapted to them. So they are written for chemical fertilizers that are produced in another way, and this is hindering, let's say, the potential of the biowaste application in the agronomic sector. So I think this is one of the main challenges, and also, how the products need to be prepared in order to be used. And as Sara says, so it can be okay in one country, but then when you come to the neighbor, it doesn't work anymore. So you need to recheck from the beginning and check country by country and even locally or regionally how the policies looks in order to really valorize this biowaste.
Thank you. Belén, one thought on this?
Yes, in our case, as Sara said before, at the beginning of the project, we had to prepare or to join all the information related with policy regulations and to identify the abundant regulations for each of the valorization paths. This is, I think that this is a very big challenge to identify and to work in the safety way in the correct way is a big challenge. And in our case, apart from the 4 valorization paths, we are working in the blend some of the feedstock. So the results are different as we plan in previous projects. So we have to look for the updated regulations, and it's very, as I said before, very abundant at all the levels, local, regional, national, European. You have to be very, very updated to work and not waste time. So it's challenge, I think.
Thank you, Belén. So in the Q&A section, there was one that probably is directed to you, Belén, because it was done during your presentation. So what is crystallization after anaerobic digestion?
Is for me, Julio?
Yeah, for you. Maybe
Belén, I think you're muted.
Sorry, now yes.
Yeah.
Can you hear
Okay.
me? Okay.
Yeah.
Sorry for that. As you're asking me about the crystallization.
Yeah.
Yes, this is the final step in the end-to-end from processing wastewater. And this is after the anaerobic digestion. The following step is the crystallization of about the product you get from the anaerobic digestion to get the end extrude. This is the last part of the bioprocess of that valorization route.
Okay, then we have a very long question that probably it will take some time to answer. So what are the concerns regarding the economic viability and long-term sustainability of these practices? Is the long-term use of valorized biomass economically viable compared to synthetic fertilizer? Is it also able to deliver the necessary nutrients required to improve crop yields as compared to the use of synthetic fertilizer? Any research results to back this up? So who wants to start?
I can answer if you want.
Yeah.
So, of course, this is one of the main questions when we were, let's say, designing the project, that use of biowaste is sometimes not really backed up by results. So in this case is why, of course, 4 years of project is too short, this is true, but it's why we are going to do pod testing and also field testing to check that these products are really reliable and we can obtain similar or even better results than with the synthetic fertilizer. In our case, it's not a fertilizer itself, it's a soil improver, but well, we can also find soil improvers in the market. And there is this tool that will be developed that will take results from the soil testing and will be modeled in order to really test in the long term or model in the long term, simulate, let's say, that the expected result, the expected impact can be ensured in years. So at the end, that, for example, including biochar in soil is not reversing the situation, meaning reversing, but worsening the situation, but it improves, and also maybe in the best case, it can sink carbon. So we have a two-side solution. So not sure if I answered the question. Well, about results to back it up, we expect that by the end of the project to be able to share different papers and publications. So to answer all this question and hopefully to be providing to the market a new product that is better than what we have right now.
Sure, because yeah, these projects are exactly addressing these topics, and in 2 years' time, when they have come to their conclusion, there will be certainly more results to back it up. I don't know if Sara and Belén, you want to add something on this point?
Yes, if I may, I will add a consideration about the economic part, maybe about the economic viability. If we look at the value chain of biowaste valorization into soil improvers from a city point of view, it is sometimes it's not really viable from an economic point of view to manage waste, because waste are a huge burden. And looking at the value chain as a linear value chain, usually it's not economically viable. And what we saw also by studying different business models that are available on the market is that it is very important to transition from the linear models to the circular one, where you consider to valorize all the outputs and side streams that come from the value chain. Also, another important factor that we analyze, especially in the cities, could be the waste charging system policies. So what we are doing is also studying how these policies and waste charging fees can be implemented in cities to support biowaste management. For sure, biowaste valorization instead of fertilizers require a very structured value chain. But we should have a lot of environmental but also organizational advantages that should somehow back up also all the cost. And we hope with our business models and business plan that are part of our project concepts, also to provide some example of how this value chain can be economically viable.
Thank you very much. Belén, you want to add something on this?
Well, from my point of view, I agree with them, and only to add that I agree with this very, very important to analyze the economical point.
You're muted. I don't know why.
Sorry,
Yeah.
sorry, but taking into account that there are a highly energy consuming to produce fertilizers. We know that 1.2% of the world's energy is used in fertilizers production. So we have a wide range to improve that figures. But of course, it's important to take into account the economic analysis. Yes.
Okay. Thank you very much. So we have come to the conclusion of our webinar. I would like to thank you all for your interesting insights and your nice presentations. To our attendees, I would like to remind that we will post soon the recording of the webinar and the presentations that you just saw. You will find them in the news sections of the 3 projects. I posted in the chat the links to our website, and they are all present on LinkedIn. So if you go through LinkedIn, you can always be updated on the latest publications, latest activities, and also the follow-up of this webinar. So thank you again to all the participants, to our speakers, and hope to see you soon in another joint initiatives of Bean2Bean, FENIX, and bioSOILUTIONS. Have a nice day.
Thank you, everyone.
Thank you. Thank you.
Thank
very
you.
much.